Envision a tank of such immense proportions that no bridge in Europe could bear its weight. A machine so heavy it tore up the very roads it traveled, and so heavily armored that virtually no weapon of the Second World War could penetrate its front. This was the Maus, a beast conceived to be unstoppable, yet a project doomed from its very inception. This is the story of the largest tank ever constructed, a machine that defied logic, and yet, somehow, came to be. It is often remarked that in the final years of the war, Germany was in a battle against reality itself. While its engineers were still capable of creating theoretical marvels on paper, the Reich was collapsing under the weight of its own internal contradictions. This stark contrast is perfectly encapsulated in the creation of the Maus. Weighing nearly 200 tons, it was less a tank and more a mobile fortress, the physical embodiment of a regime's belief that victory could be achieved through sheer scale, steel, and intimidation. Even today, the Maus feels less like a historical vehicle and more like something wrenched from a fever dream. To grasp why this behemoth was created, we must return to the desperation that defined 1942 and 1943. The German army had faced catastrophic defeats on the Eastern Front. The loss at Stalingrad was not merely a military setback, it was a psychological cataclysm that shattered the myth of German invincibility. A creeping dread began to permeate the Wehrmacht. They were confronting an enemy whose industrial capacity vastly outmatched their own. As the Red Army deployed tanks by the tens of thousands, German leadership sought anything that could reclaim a sense of battlefield dominance. It was in this climate that Adolf Hitler grew increasingly fixated on Wunderwaffe, or miracle weapons. He held a conviction that a single revolutionary technological leap could fundamentally alter the strategic balance of the war. This mindset, a steadfast refusal to accept the cold arithmetic of industrial warfare, paved the way for the most extreme concepts. And few concepts were more extreme than a super-heavy tank that weighed more than some naval destroyers. The vision for the world's largest tank was born from a confluence of fear, ambition, and personal obsession. The most pivotal figure on the engineering front was Ferdinand Porsche. A man renowned for both his genius and his ego, Porsche was captivated by the notion of pushing technological boundaries far beyond the scope of conventional military thought. He held that future conflicts would be decided by gigantic, heavily armored machines capable of crushing enemy defenses through sheer mass. Whether this was a genuine strategic conviction or a shrewd appeal to Hitler's known admiration for oversized designs remains a topic of historical debate. Regardless of his motives, Porsche proposed a super-heavy tank project, initially designated Tip 205. It would soon be given a far more iconic name, Maus. From the earliest design stages, the specifications were staggering. The projected weight ballooned from 100 tons to 120, then 150, before finally settling near 200 tons. The tank's frontal armor was to be of a thickness that no contemporary anti-tank gun could reliably defeat. Its main armament was a 120mm cannon, a weapon typically reserved for fortified bunkers or specialized tank destroyers. As if that were not enough, a secondary 75mm gun would be mounted alongside it. Yet, a critical element was absent from the proposal: a practical plan for its combat deployment. Engineers within the German army were perplexed. They raised questions about how it would cross rivers, how it would be refueled, how it could be transported, and how it would cope with the inevitable need for field repairs. The stark reality was that Germany's logistical infrastructure was completely unprepared to support a machine of this magnitude. Even the factories faced immense challenges. Constructing a single Maus consumed vast quantities of high-grade steel that the Reich could no longer afford to spare. Despite these serious reservations, the project advanced, driven not by strategic logic, but by the increasingly desperate fantasy that a single superweapon could still win the war. By late 1943, the Allied bombing campaigns were relentlessly punishing German industry. Fuel shortages were reaching a critical point. The Eastern Front was consuming men and materiel at an unsustainable pace. In the face of all this, resources were still being diverted to create a tank too heavy for any bridge, too slow for any battlefield, and too complex for any supply line. It was a machine that was indestructible in theory, but utterly impractical in reality. Ultimately, the Maus became the supreme symbol of this contradiction. A technological masterpiece conceived at the worst possible moment. A vehicle whose existence spoke more to the psychological state of the Third Reich than to its military requirements. It was the largest tank ever built, and perhaps the most definitive example of what occurs when engineering brilliance collides with strategic delusion. By the midpoint of the war, Adolf Hitler had cultivated a fascination with weapons that defied conventional military wisdom. In his view, victory was attainable not through consistent production or coordinated strategy, but through shock, intimidation, and the creation of machines so advanced and immense that they would break the enemy's will to fight. This belief evolved as the realities of the war turned against Germany. Each setback only reinforced his conviction that something extraordinary was needed to reverse the tide. It was a conviction that men like Ferdinand Porsche knew how to leverage. This obsession was not an isolated phenomenon. The plans for the Maus existed alongside other projects that verged on the fantastical. The Rate land battleship, a concept so enormous it was more akin to a naval cruiser on tracks. The V-2 rocket program, which drained resources to create a terror weapon aimed at London, and oversized artillery pieces that required entire battalions for transport. These projects were born not of strategic need, but of a dangerous mix of ego, ambition, and delusion. Ferdinand Porsche thrived in this environment. Daring and often dismissive of practical constraints, he was fascinated with designing vehicles that broke the established rules of warfare. Having already earned Hitler's favor, Porsche was given considerable freedom to explore experimental engines, novel suspension systems, and electric drive concepts that most military planners deemed too complex for combat. The super heavy tank was a natural extension of their relationship. Porsche understood Hitler's admiration for size and exaggerated power over battlefield efficiency, and he designed his proposals accordingly. The Typ 205 project, which became the Maus, was meticulously crafted to appeal to this obsession. Porsche envisioned a machine immune to nearly all enemy fire, a tank capable of smashing through defensive lines by its mere presence. It promised invincibility, and at that juncture in the war, the illusion of invincibility was far more compelling to Hitler than any sober military analysis. Even in the project's infancy, the German High Command expressed unease. Senior officers raised concerns about everything from its projected weight to its engine requirements. They questioned how such a machine could be transported, how it could cross bridges, and how it could maneuver on the front lines. Field commanders worried the Maus would be little more than an expensive static pillbox, a steel monument to wasted resources. The objections were valid and numerous, but in the political climate of 1942, few dared to openly challenge Hitler's preferences. As engineers debated, the project only grew in scale. Hitler demanded thicker armor, greater firepower, and even experiments with underwater crossing systems, as if sheer engineering ingenuity could suspend the laws of physics. The result was a tank whose weight spiraled beyond all practical limits. While some within the Wehrmacht argued that the same steel and labor could produce dozens of proven medium tanks, their pleas were ignored. Size, not quantity, had captured the regime's imagination. At the heart of this story lies a strange paradox. German engineers were among the most skilled in the world, capable of designing machines of astonishing precision. Yet, they were increasingly forced to operate within a system governed by ideology and personal whims. This tension resulted in weapons that were technologically impressive, but strategically irrational. The mouse is the most prominent example of this contradiction, but it was far from the only one. As the war progressed, Hitler's fixation on monumental weapons only grew. He dreamed of tanks that could shrug off any Allied shell, guns that could level cities, and rockets that could traverse continents. But these fantasies consumed resources that Germany no longer had. The industrial base was shrinking, fuel reserves were dwindling, and skilled labor was becoming scarce. With the Allies dominating the skies, any large-scale production was vulnerable. And yet, the Maus project continued. It persisted because it offered a psychological sanctuary. It allowed the leadership to believe in a decisive breakthrough that would validate their claims of technological superiority. It gave engineers like Porsche a platform to pursue daring concepts without restraint. And it enabled Hitler to convince himself that victory was still achievable, if only the next miracle weapon could arrive in time. The reality was starkly different. Giant machines cannot win wars when a military's foundations are crumbling. Super-heavy tanks cannot compensate for collapsing supply lines, dwindling manpower, or overwhelming enemy production. Still, the Reich poured resources into the Maus, as if to will it into success. It was an act of both engineering ambition and profound denial. By the end of 1943, these contradictions were impossible to ignore. Germany struggled to produce enough conventional tanks to replace its losses. Fuel shortages were catastrophic. Entire factories were being obliterated by Allied bombing raids. Amid this chaos, work on the Maus continued, consuming steel, labor, and time that the Reich could not afford. It was the perfect symbol of the regime's priorities, colossal, impressive, and utterly divorced from the reality of modern mechanized warfare. The Maus was more than a tank. It was a reflection of the mindset that created a mindset that believed size could replace strategy, and that engineering miracles could substitute for sound planning. The deeper one delves into the technical design of the Maus, the more apparent it becomes that this vehicle was shaped not by battlefield realities, but by ambition, political pressure, and the conviction that engineering brilliance alone could conquer any practical obstacle. On paper, the Maus was a masterpiece of steel and firepower. In practice, it was a puzzle with no right answers. Every advantage it offered created a new, often insurmountable, problem. The initial specifications were breathtaking in their scale. The frontal armor was designed to be of a thickness unheard of at the time, capable of withstanding direct hits from anti-tank guns that would obliterate lesser vehicles. The turret, a massive block of steel more akin to a fortress gun emplacement, weighed more than some entire tanks. And within that turret sat the armament that defined the Maus, a 128mm main gun paired with a 75mm secondary cannon. This choice of armament was revealing. The 128mm gun was originally designed for long-range tank destroyers, able to penetrate heavy armor at distances where return fire was ineffective. It was overkill for conventional tank combat, but the designers insisted that the Maus required overwhelming firepower to justify its immense size. The secondary 75mm gun provided tactical flexibility, allowing it to engage infantry or lighter vehicles without expending the massive main gun ammunition. However, moving this behemoth was the greatest challenge. The Battle of the Maus was fought in the engine compartment, where engineers grappled with a seemingly unsolvable problem: how to propel a vehicle of nearly 200 tons without it becoming immobile or catastrophically unreliable. Conventional tank engines were wholly insufficient. This led Porsche to propose one of his most audacious ideas: a diesel-electric transmission. In this system, a large internal combustion engine would function as a generator, producing electricity to power electric motors that drove the tracks. Theoretically, this would provide smoother acceleration and superior torque. However, the system required enormous amounts of copper, a resource Germany critically lacked. It also generated immense heat, compounding the already significant cooling challenges of such a heavily armored vehicle. The complexity of the electrical system also created maintenance issues that would be impossible for a frontline crew to manage. The suspension and track system posed another daunting challenge. A tank of this weight would crush conventional components. The engineers developed an elaborate interleaved suspension with massive, overlapping road wheels. The tracks themselves were incredibly wide to distribute the tank's ground pressure and prevent it from sinking. Even so, the Maus was highly susceptible to becoming bogged down in mud or soft terrain. Inside, the crew compartments were spacious compared to other tanks, yet they were crammed with machinery, cabling, and ammunition. The sheer scale of the components made even routine maintenance a physically demanding ordeal. The tank's weight also created a strategic problem that no amount of engineering could solve: transportation. No bridge in Europe could support it. The proposed solution was an underwater snorkel system for crossing rivers, an inventive but absurdly risky idea that ignored the realities of combat. It is clear the Maus was not just ambitious, it was an impossible machine. The engineering was impressive in its isolated parts, but as a whole, the vehicle was a cascade of interconnected problems. The armor demanded a larger engine, the engine required more space, the space increased the weight, and the weight required a stronger suspension, creating a vicious cycle. By the time the blueprints were finalized, the Maus had drifted far from the actual needs of the German army, designed to be awe-inspiring rather than effective. For all its armor and firepower, the Maus was saddled with limitations so severe that they negated every promised advantage. It was a titan of engineering built on a foundation that could not support its own weight. The most glaring limitation was its mass. At nearly 200 tons, the Maus was the heaviest tank ever built, a distinction that sounds impressive until one considers the realities of a battlefield. Terrain is unpredictable and often hostile to heavy machinery. For the Maus, Natural obstacles like mud and snow were magnified to an extreme degree. Its massive tracks left deep trenches in the earth, a clear sign that any machine of this size could not move without reshaping the ground beneath it. A tank that cannot move reliably is not a weapon. It is a bunker waiting to be outmaneuvered. Then there was its speed. Under ideal conditions, the mouse could barely move faster than a walking pace, making it slower than the infantry it was meant to support. In an era of warfare that prized speed and maneuver, such a slow vehicle was a liability. An enemy could simply avoid it, encircle it, or disable it with indirect fire. Furthermore, its massive, lumbering form would have been a dream target for Allied fighter-bombers, who by 1944 controlled the skies. The tank's logistical needs were equally crippling. Transporting it by rail was nearly impossible. Supplying it with fuel was a monumental task, especially as Germany faced critical shortages. The resources required to keep a single mouse operational for a day could have supported an entire battalion of conventional tanks. Maintenance was another nightmare. The complex electric transmission required specialized technicians and tools that were simply unavailable on the front lines. Strategically, the mouse violated a fundamental principle of armored warfare: flexibility. Successful tanks like the American Sherman and the Soviet T-34 were practical. They could be mass-produced, easily repaired, and deployed in large numbers. The mouse offered none of these advantages. It was spectacular on paper, but deeply compromised in any real-world scenario. Even its armor had hidden drawbacks. While the front was nearly invulnerable, its sides and rear were not. The thick armor also created tremendous internal heat, degrading crew performance and increasing mechanical strain. And the problem of crossing rivers remained unsolved. The proposed underwater snorkel system was operationally suicidal. Any malfunction would have turned the tank into a steel coffin for its crew. Taken together, these limitations reveal a painful truth. The mouse was not a practical weapon of war. It was a monument to ambition, a machine forged in an environment where political pressure overshadowed military necessity. Its immense weight, slow speed, crippling fuel demands, and logistical burdens ensured it would have been more trouble than it was worth on any battlefield. Transforming the mouse from ambitious blueprints into a physical machine was an undertaking that strained the German industrial system to its breaking point. Two prototypes, designated V1 and V2, were constructed. Each required massive quantities of high-grade steel and specialized components, all while factories were under constant Allied bombing and facing material shortages. The hull's armor plates were so thick that standard rolling mills could not form them, requiring enormous presses and heavy machining. Assembling the interior was a dense maze of cables, tubing, and heavy hardware. The massive turret, weighing more than many entire tanks, presented its own challenges, from installation to the engineering required to handle the recoil of its powerful 128 mm gun. The first prototype, V1, was assembled without a functioning turret to test mobility and the electric drive. Initial trials on flat, solid ground showed it could move with a heavy precision, but problems were immediately apparent. The electric drive system overheated, the ground shifted under its weight, and cooling fans struggled to keep temperatures manageable. The second prototype, V2, was completed with a fully functional turret and armament. Trials demonstrated its devastating firepower, but also revealed that firing the main gun placed severe strain on the turret and internal systems. Mobility tests were even more disappointing. The tank remained too slow for any realistic combat scenario, and crossing even minor obstacles was a hazardous endeavor. Ultimately, the practical questions of deployment, repair, and supply all led to the same conclusion. The Maus required an infrastructure and logistical network that Germany no longer possessed. Factory reports grew increasingly pessimistic. The prototypes consumed vast resources, but offered no strategic value. By the time they were completed, it was clear to all involved that the Maus could never become a mass-produced weapon. It was too heavy, too complex, and too slow. And yet, the story was not over. The final months of the war would bring chaos and destruction, sealing the fate of the world's largest tank before it ever saw combat. As the war entered its final catastrophic phase for Germany, reality delivered its verdict on the Maus. The project, born of ambition, now faced the undeniable truth that the machine was simply unusable in real combat. The core issue remained mobility. Modern warfare demanded speed and maneuverability, neither of which the Maus possessed. It was slower than infantry and could be easily immobilized by damaging its tracks or suspension. Once stationary, it was just an expensive target. Fuel was another insurmountable barrier. By 1944, German fuel shortages were so critical that entire divisions were immobilized. The Maus, a notorious gas guzzler, could not be deployed in an army that was rationing every drop of fuel. Infrastructure posed a further challenge. No bridge in Europe could support its weight, and the proposed underwater crossing method was operationally suicidal. Rail transport was equally untenable, as the Maus was too large and heavy for standard rail cars and vulnerable to the Allied air power that now dominated the skies. A tank that could be destroyed before it even reached the front is a liability, not an asset. Crew training for such a unique and complex vehicle was another impossible hurdle in the final years of the war, when experienced personnel were increasingly scarce. Strategically, the Maus fit no established German doctrine. It was too slow for blitzkrieg and too inflexible to serve effectively as a defensive weapon. Ultimately, the timing of its creation sealed its fate. The Maus emerged when Germany was fighting on collapsing fronts, with dwindling resources against an enemy growing stronger by the day. To invest in a tank that demanded such extraordinary resources was not just impractical, it was strategically incoherent. The Maus possessed immense armor and firepower, but it lacked the one thing that mattered most: feasibility. It was a machine whose strengths existed only in isolation, divorced from the harsh realities of war. By the time the Maus prototypes were complete, the Third Reich was unraveling. The giant machine, once envisioned as a decisive weapon, was now stranded in a collapsing world. Its end came not in a blaze of glory on the battlefield, but in the quiet, chaotic decisions of a dying regime. As Allied and Soviet forces closed in on Germany, the testing grounds where the prototypes were held became vulnerable. To prevent the Allies from capturing the advanced technology, an order was given to demolish both machines. The V1 prototype, which was unarmed, was significantly damaged. The V2, which was fully armed, suffered only a partial detonation, leaving its hull damaged but its massive turret largely intact. When Soviet forces overran the Kummersdorf testing facility in the spring of 1945, they discovered the remains of the two prototypes. Recognizing their significance, Soviet engineers decided to reconstruct one for study. They mounted the intact turret from the V-2 onto the less damaged hull of the V-1. This hybrid mouse, stitched together from the remnants of both prototypes, was transported to the Soviet Union for analysis. Soviet reports described the tank with a mixture of awe and disbelief, noting its extreme armor, but also its critical weaknesses. They concluded its strategic value was negligible. The reconstructed mouse eventually found its home at the Kubinka Tank Museum, where it remains today, the only one in existence. It stands as a hulking monument to a project that consumed immense effort without ever influencing the war it was built for. Its end was not a dramatic confrontation, but a quiet capture, a reflection of an ideology that believed monumental weapons could compensate for strategic failure. To stand before the mouse today is to witness a profound contradiction. It is both a masterpiece of engineering and a monument to catastrophic failure. It embodies the belief that technology alone, stripped of practicality and strategic context, can alter the course of history. The mouse was born from a worldview where enormity was mistaken for invincibility. Its creators imagined a machine that would dominate through sheer mass, but wars are won by logistics, strategy, and adaptability, not by monuments. By the time it was conceived, Germany could no longer produce weapons that met the needs of its crumbling fronts. Yet, amid this reality, its leadership clung to the hope that a colossal tank could turn the tide. This reveals the psychology of a regime under immense pressure. As defeat loomed, rational strategy was replaced by a desperate search for miracle solutions. The mouse represents the endpoint of this gigantomania, the flawed belief that bigger is always better. The most effective tanks of the war, like the T-34 and the Sherman, were not the largest. They were practical, reliable, and numerous. The mouse, had it ever been produced in numbers, would have been an irrelevant drain on resources. It was a theoretical weapon, functional only when the complexities of real warfare were ignored. Its story is a timeless lesson. It is a reminder that innovation must be aligned with practical needs, and that technology without strategy is merely spectacle. The mouse stands today not as a triumph, but as a warning. It teaches us that engineering must serve strategy, not replace it, and illustrates how a once dominant military power invested its final hopes in weapons that were impressive in isolation, but powerless against overwhelming, coordinated force. The mouse never fought in a battle, yet its legacy endures not as the unstoppable war machine it was meant to be, but as a heavy steel reflection of a regime that believed it could out-engineer the inevitable. It is a titan built of ambition, shaped by desperation, and preserved as a powerful reminder of the limits of technology when strategy fails and reality can no longer be denied.